Hi, my name's Justin Langford, and I'm going to present my session on 5 mistakes with cloud data migration. Welcome to SQL Bits. I know it's a bit different for this to be delivered remotely rather than in person, but nevertheless, I hope that you find these sessions valuable and there's plenty of great content over the conference. So we'll get started with the content. I'm going to talk about mistakes that we see customers making with their cloud data migration projects. And we're fortunate in seeing tons of tons of customers migrate to cloud. Many of those organizations migrate and deliver flexible, agile, and cost-effective solutions. Other customers struggle with the cost, complexity, and flexibility. And what I've done is look across all of these projects and generalize 5 key themes where customers don't realize the full potential and possibly even make mistakes. If you're contemplating a cloud migration project, this session hopefully will provide you with some valuable insights of pitfalls to avoid and some steps that you can undertake to mitigate some of those risks. Just before we get started, a little bit about myself and Coeo. I'm one of the co-founders and a director at Coeo, and together we help clients predict their future. We're specialists in the Microsoft data platform, so our heritage is SQL Server, and we're 100% Microsoft focused, so Azure Data Services is our area of expertise. We organize our engagements into 3 areas: strategy, execution, and operations. Within strategy, we provide data maturity assessments, help clients define their data strategy and enterprise analytics roadmaps. Within execution, we deliver cloud data migration and transformation projects. We provide solutions for enterprise analytics, predictive analytics, and data science. And within operations, we provide cloud data management, including Power BI and analytics adoption and enablement. And this is provided through our 24/7 dedicated support service. Just a little bit about how this session will run. We'll start with an introduction to factors driving cloud data migration. I'll talk through the 5 mistakes, and then I'll talk through the opportunities to mitigate some of these common mistakes. When I think about problems that clients experience when they're undertaking cloud data migrations, many of these are viewed as technology problems, when in reality these problems are people problems, insofar as they don't have the skills or expertise needed to undertake and complete such a migration project. And this is really where we can help prepare ourselves and analyze the problem so that we understand what we're taking on, what to expect, and really give ourselves the best opportunity to kind of move forwards on a solid platform. So when we think about factors driving cloud data migration, I kind of think of this on a spectrum of pain to pleasure. At one end of the scale, organizations are moving for pain reasons. These could be factors such as supportability. Maybe they're running Windows Server 2008 or SQL Server 2008, which are both end of life, and Microsoft have provided extended security updates to customers running those workloads in Azure. There might be performance issues. They could be at the end of their data center contract or need to refresh servers or maybe a SAN. They could face flexibility and scalability issues. So there might be problems with accommodating peak load or peak demand in on-premise data centers, and there might be a large operational overhead. So all of these factors are pain factors which are driving customers towards a migration. At the other end of the spectrum, there's the pleasure. So these are clients that understand the benefits of moving to platform as a service, and they want to move to Azure for the proximity to PaaS, which will enable them to make an incremental and iterative migration and really undertake a PaaS transformation project subsequently. Additionally, there are some cloud-only offerings, particularly in the modern analytics space. So clients that are thinking about evaluating Databricks, machine learning, many of the cognitive services and predictive analytics technologies, those are cloud only. And in order to benefit from those, clients often need to co-locate the data in the Azure platform such that they can start enabling some of those resources. Agile infrastructure is another important benefit, which means that we can scale up and scale out to accommodate peaks in demand and workload. And we can also reduce the operational burden. So taking away patching, backups, high availability and disaster recovery being provided out of the box are real key benefits for many organizations. Microsoft recently announced that Windows Server 2019 distributed on Azure avoids the need for restarts following patching for 6 months. And I really feel as though Microsoft is beginning to understand the pain that many customers have endured over all these years with having to schedule patching cycles and restart frequencies with application interruption and needing to communicate that to the business. So it's great to see many of these things actually taking place and enhancing the service that's available and offered in Azure. So that gives you some overview, and really, when I think about the customers that are migrating to Azure, they're doing so for one or both of these reasons. Either they're driven by pain through contract renewals or aging hardware, or they're driven through the desire for a new modern platform. And many organizations have both. So they might have some aging hardware and they want to undertake modern analytics projects. Needless to say, as with most human beings, pain is often the strongest emotion and the strongest driving force when we're undertaking these types of projects. So there's often a compelling event and a reason why organizations are undertaking the migration, which has a hard deadline with maybe a data center or networking contract being up, or a supportability issue around Windows. So it's really important, and working to those deadlines means that we may need to adjust and factor the scope and the scale of modernization in context of the migration. So lots of us would like to, in a single step, move from an on-premise data center to the latest and greatest PaaS services in Azure. However, the time and the risk involved with those projects are often factors which will cause us to reduce the scope of the project. So many of these types of projects start out with a very ambitious remit to fully modernize to platform as a service. But the reality of the timescales and the risks involved in the migration mean that we have to moderate our ambition. And frequently we finish up with a lift and shift migration. So we move the environment as is from on-prem into Azure, and then we subsequently modernize. And that has the benefit of allowing us to modernize components of the application and really re-architect in a microservices fashion and test and evaluate each of those components piece by piece as we move through. So without further ado, I'll get started with the first mistake, and this is around cost. So there's a number of dimensions to this. I've kind of grouped my thinking into 4 categories, and I'll start off with the commercial mistake. And here I see customers not taking advantage or not using their Azure hybrid user benefits. So this allows customers to take their licenses for Windows and SQL Server from their enterprise agreement, and as long as they have software assurance, they can transfer those license rights through to Azure. So that means that where they own the license and they've got active software assurance, they can rent a Linux virtual machine, so just the vanilla virtual machine, because they already have the right to use Windows and SQL Server. Combine that with reserved instances, and reserved instances is an opportunity to pre-purchase, make a commitment to compute and blob storage, and that's available in 1 year's or 3 years commitment, and can attract significant discounts also. And together, so if we combine the Azure hybrid user benefits and the reserved instances, organizations can enjoy up to 80% discount on their costs with Azure. So I've seen a number of organizations that have the opportunity to use their hybrid use benefits and reserved instances, but have chosen gallery images from Azure. And those gallery images are billed by the minute, and that will include Windows and SQL Server licensing. So those organizations are effectively paying twice because they already own the license and the right to run that workload. And if they've got active software assurance, they have the license mobility rights, which allows them to move that workload across to Azure. But nevertheless, they've made a mistake. They didn't understand what they're entitled to, and they paid twice for the license. So a really big opportunity there to trim back and rationalize the licensing. Second point there is really around dev test subscriptions, and this is an offer from Microsoft which makes it much more compelling and cost effective for organizations to run those non-production workloads in Azure and still provide full functionality to developers. So really worth exploring. If you're not already using those, then consider that. I've recorded another SQL Bits session which is purely focused around cost optimization in Azure, and it goes into much more detail around many of these benefits. It's called Azure Maximize Your Bang for Buck. So if any of these points resonate or you want to find out more about it, I'd encourage you to check out that session. It's just 20 minutes and it just provides a deeper dive insight into some of those benefits. The second point is around governance. And really what I was thinking here is cost control, budgeting, reporting, deployment and access. And I really think that most people working in infrastructure, DBA roles, we might get involved occasionally in budgeting and finances, but we're not frequently accustomed to having to make a spend forecast and then actively monitor that on a day-to-day or week-to-week basis. And really, when we move to Azure, this becomes absolutely critical for making sure that we're on track and our month-to-month spend in month 1 and month 12 of a fiscal year is on track, and we really understand that. And coupled with deployment and access control, this really means that organizations take seriously and monitor how many users can provision resources, and separating production and non-production subscriptions such that we have sandpits and we enable developers to innovate and to test out and evaluate new technology, but we also have the right governance and control around the cost optimization there. And I don't think that lots of organizations build this capability in. And we've all heard horror stories of customers where they provision 16 or 32 node Hadoop clusters and forget to switch it off over the weekend. And this is really around making sure that we've got the right triggers, the right reporting and access control set up such that we catch those issues before they become problems. And we really make sure that we don't make those mistakes and avoid them. The third point here is technical. Lots of organizations have legacy apps and a high degree of technical debt and really thorny applications that are difficult to modernize. And this can be a pain when moving to Azure from a cost perspective, because we may need to over provision resources and co-locate applications and databases in order to achieve the right level of performance and scalability that we enjoy on premise. So I kind of group a few different things here together around legacy apps and the technical debt, because this can be really challenging in order to manage cost where we have expensive long serving application stacks. So it's really important to try and at least be aware of that and have a roadmap to modernize. And the final point is around expectations. And a number of organizations and CFOs that I speak to think that they will save money by moving to cloud. And it is possible to save money with cloud, although that's mostly available in PaaS solutions. And we know and understand that this requires a level of engineering effort and development investment in order to transform and refactor code for platform as a service. But fundamentally, we can save money if we undertake that. So my observation here is organizations that migrate to Azure with the expectation purely of saving money when they move to Azure may be disappointed. So really thinking carefully about what your motivations are. And if your motivations are to reduce friction, improve agility, transform over time to PaaS, and then dial down the number of virtual machines that you're running, then I think that's reasonable. If you expect to decommission an on-premise or co-location data center and lift and shift to Azure and save money, you're probably going to be disappointed there. And a really small aside, but one of the things that came up recently was around database restores and verification. And one of the organizations that we were working with had an on-prem data center. They were backing up their SQL Server databases to Blob Store in Azure, and they noticed a increase, an uptick in their network egress charges. So transferring data into Azure is free. Pulling data out of Azure is charged and paid per gigabyte per month. So this organization were using Azure for disaster recovery. They were writing the backups from their on-prem environment to Azure, and they used the database backup verification and option of SQL Server, which is a smart thing to do to make sure that those backups are verified after they've been written. When they changed the backup destination, the target for the backups from their on-prem backup destination to an Azure Blob Store, what they didn't consider was that database restore verification or database backup verification process would require that entire backup to be read back across the network into their virtual machine that runs in the on-prem data center in order for that verification to take place. So a relatively innocent or trivial act of restoring backups, which is a good best practice and most DBAs would recommend, can turn out to be a costly mistake in terms of managing the network egress charges. Now, they were able to catch this pretty early on. It cost a few £100 already, but they could extrapolate that, and that would have cost a serious amount of money in terms of several thousands of pounds per month, every month, if that hadn't been caught. We were able to actually put an interim or workaround solution, which did work out more cost effective and still allowed the backups to be verified. That involved spinning up a small VM in Azure and running a restore verification to that VM and then tearing down the VM. And this meant that we meet the objectives of ensuring backup integrity, but without the network egress charges. So that was a smarter way to work. The second mistake is around readiness, and I kind of collected a few different thoughts here. And I'll start off with the team and roles and responsibilities. And I think that when we're working in an on-prem data center, we have some very clear expectations around infrastructure, DBA, and development tasks and activities. And when we move to Azure, for some reason, there is a lack of maturity and a lack of communication and expectation around those roles and responsibilities. And what role will the developers take, and how much control and access do they have to production environments? And that there's a number of different things that can go wrong here, as I'm sure you can imagine, but adhering to separation of duty requirements and making sure that we've got the right level of access, but only the right level of access, and the principle of minimal privileges is really important. Second point is really around skills. So preparing for go live, taking certifications. Microsoft have got some great role-based certification now. Learning from mistakes, and by that I mean making mistakes in a small way and learning from them. So I think it's really important that everybody understands if they disconnect the storage from a virtual machine or delete some disks or delete some backups, what are the process to restore or recover that service and get things back up and running. And these are mistakes that as database guys and girls early in our career will have made many of these mistakes and restarted the wrong server and detached a database accidentally, and we'll have learned from those mistakes, and more established in our career we won't make those mistakes. But we need to be honest with ourselves and acutely aware of our own capability and limitations. So let's make those mistakes in a low impact way, maybe with a dev test environment or with back office applications for that only affect the IT department, and that's a good way to approach it. This is closely coupled with growth mindset, and if you haven't come across growth mindset, then I think it's a really valuable asset to be able to talk about and to think about. And this concept really refers to the fact that as individuals, we can either have a growth mindset or a fixed mindset. Someone that has a fixed mindset assumes that they know everything that they need to know and they've learned everything that they need. And someone with a growth mindset is open to learning new things, making mistakes, but learning from those and moving forwards. And I think that there's a healthy conversation to have here with teams around having a growth mindset, not being afraid to make mistakes and learn from those mistakes and talk openly about it. And then the final point there is or the next point there is around CI/CD testing and approach. So to unlock many of the benefits of Azure, we need continuous integration, continuous deployment, testing and approach. And in a software-defined data center, application and database releases often include infrastructure releases, so network changes, network load balancer changes, and the scope and remit there, and really to unlock the benefits of Azure, we need this DevOps mentality and approach to source controlling infrastructure code and really managing and maintaining the infrastructure and application and database together in harmony. So being conversant and understanding that DevOps approach and mentality is really important, and the whole team building the skills that are necessary there is vital to really unlocking the value of cloud. Next point is around monitoring, and lots of organizations, this is an afterthought. How are we going to move to Azure first and then worry about tooling and application performance monitoring, and what's our service desk processes, and to a certain extent that maps to the first point in roles and responsibilities. There's a lot of telemetry available in Azure and a lot of cool features, including app insights that provide deep application knowledge and monitoring. But as with any on-prem monitoring, it's exactly the same in cloud. It needs to be configured and customized with alerts and thresholds that are meaningful and valuable for your workloads in your application, in your environment, and they don't result in tons of false positives. But when someone does receive an alert, they absolutely know that intervention is required and what's involved. So really focusing on that. And the final point here is around security. So role-based access to non-production environments. How do we provide test data in non-production environments in a safe and controlled way, making sure that individuals have got principle of least privilege, they've got access to the resources that they need to do their job, nothing more and nothing less. And this really dovetails into a whole realm of cloud native security resources. So there's a lot of features in Azure SQL database called advanced threat protection, which enable us to create a baseline for user access and connectivity, and then to block non-typical or atypical access and really configure that. As database engineers and professionals, we need to learn about cloud native firewalls, Sentinel, and a whole suite of security tools and products that are required to protect our data and our resources when they're in Azure. And I also consider that this includes resources in Azure, because it's really, really easy to provision resources and it's really easy to delete them. And there are features such as resource locks, which allow us to create a lock on a resource which will protect against accidental deletion. So really being comfortable and understanding those features is important in order to be able to manage and maintain the environment safely and securely. The third mistake is around design, and the first point here I included as architecture. And for this, I really think organizations that struggle with Azure design solutions as though it's their own data center, and they might create solutions and templates and blueprints completely from scratch, where there are a number of architectural standards and blueprints that that organizations can leverage, which means that they can focus on the aspects that are unique for their organization. So we don't need to be burdened with starting with a blank piece of paper. There are accelerators available from Microsoft and other partners which can help shorten that curve and enable the foundation elements of Azure, which means that engineers and staff can focus on the bits that are unique to their organization without necessarily needing to reinvent the wheel. The second point here is around application lifecycle management. So we already talked about technical debt and legacy applications. Really identifying and knowing what the longevity or the lifetime of those applications are so that you can decide how much effort to invest in modernizing that application, or perhaps leaving it to sit and rot and making sure that it's fed and watered, it has the minimum level of performance and protection, high availability and disaster recovery needed, but nothing more and nothing less. If it's going to be superseded and end of life, then we don't need to worry about investing a lot of effort. But if there is an application which does need to be does have a long roadmap and a long lifetime inside your organization, then we will invest the effort to ensure that that is performant, scalable and robust and resilient. I also consider that this is we need to really think about how we provide those non-prod environments. How do we test migrations? How do we think about the network connectivity between remote offices and home workers and Azure to make sure that they get the right level of end user experience and performance that's available? The next point around governance and cost modeling and justification. So really thinking about the design of resources and resource groups in Azure and how we'll tag those resources such that we can attribute cost appropriately, and that's done at the right altitude. So if we are recharging prod and non-prod resources to projects or business teams, then we've configured the subscription, the resource groups and the tagging to enable that down the line, because it's very hard to retrofit that, although not impossible. It's much easier if that is thought through and planned out from the outset. And the final point is expectations. And I think that this really dovetails with the kind of DevOps, continuous integration, continuous deployment topic, in that some leaders in organizations can misbelieve that they when they move to cloud, then they get a DevOps agile environment. And the reality is that if they're undertaking a lift and shift migration, they end up with more or less the same technology stack running in someone else's data center. And that's really important because this is a DevOps project, and a CI/CD project is essentially a totally different modernization project that could be undertaken on premise or could be undertaken in the cloud. And the vision that many IT leaders have is that they're operating in the right combination of cloud platforms and with a DevOps mindset and solution with the right agility and platform. So, I just wanted to signpost and separate the fact just because we're running in cloud doesn't mean that we've got a DevOps platform, and that enables us to have that release mechanism. But essentially, we can just migrate technical debt if we're not careful. And the modern platform is really aligned. So just because we're running in cloud doesn't mean that we're not running SQL Server 2008 on a VM. We really need to focus on that as well. Mistake number 4 is focused around performance, and I included the quote here: bad queries cost money. And I think this is really pertinent because we often find customers that have 32 core or 64 core virtual machines running on premise, and they might run at 40% CPU or 70% CPU. And everybody looks at that server, and that might be a SQL Server Enterprise Edition investment of £300,000 or £400,000 in cost. And people generally think that generally view that those workloads are productive and are effective. But when they move that workload into Azure, and this requires a virtual machine that costs £10,000 a month or 30 or 40,000 pounds a month, suddenly their attention is drawn to that very real operational expenditure, OPEX cost. And there is a direct and meaningful benefit through performance tuning and optimization of those queries to make sure that we've got the right size VM and we've got the right query structure and plan, and we've got the right indexing strategy and database maintenance strategy to make sure that we're as efficient as possible when we run that workload. And there's a real and direct return on investment for all of this endeavor, which means that it's really valuable to performance tune and optimize, and we can get the right level of expertise at the right level of investment to achieve a good return on investment. I also think about scalability and performance, because the number of hops between an application and a database in an on-premise environment can be far fewer, and even I've known customers that co-locate application VMs and database VMs for particularly chatty application workloads on the same ESX host, the same hypervisor host. And then when we disaggregate those VMs, when they run in a cloud data center across different hosts, there may be many more layers of the network in order to traverse, which means that we need to compensate by over-resourcing on VMs and network throughput in order to compensate for that chatty application and ineffective app design, which means that we previously had to co-locate those VMs. The next point is around complexity, and there's complexity at a number of layers here, which require a higher degree of troubleshooting skills. We're abstracted from the platform. If we're in a PaaS world, we can't remote desktop, we can't run perfmon. So there's a whole new world to learn, particularly if we're running with elastic databases. We've got the same schema duplicated many times, and a particular user has a stored procedure that times out or has poor performance. If you imagine parameter sniffing issues and plan cache issues, as soon as we multiply or divide that schema across 10 databases, 100 databases, 500 databases, the skill and level of expertise required to diagnose and resolve a performance issue at that level becomes significant. The third point here is around testing, and this is really creating a benchmark pre-migration, so really characterizing and understanding application and functional performance testing on-premise, getting the business engaged in pre-migration testing so that we understand and we're confident in that migration effort and expectation, and really making sure that we're informed and we know what good looks like from a performance and functional point of view. And the final point, I keep coming back to expectations, but this is one of the things that I see frequently is we have poor performance on premise, so we move to cloud because we think that's going to solve our problems. And, I think that this is often golf course chatter when people are thinking about bragging on the golf course that our entire workload moved to Azure and it solved all of our problems. The cloud vendors would love that to be the case. The reality is that if we lift and shift workload, it's unlikely to solve many problems. We need to invest the engineering effort, the development time to understand, characterize, diagnose those problems, and then re-platform where necessary. And mistake number 5 is around maintenance. And I think here there are certain aspects or dimensions to this, but thinking the cloud vendors and Microsoft included have done a great job on positioning cloud as being self-healing, auto-tuning, self-maintaining. And the reality is that there's still a lot of work required in order to manage and maintain. So sure, we don't need to patch if we're running in PaaS services, and maybe we don't need to back up, but there's still a lot of work, engineering effort to be done in order to provision, manage, maintain, and optimize those environments. There's a lot of chatter around whether DBA is the right term. I think that data engineer, effectively that individual is a custodian of the data and responsible for engineering the platform, but that requires a much more broader skill set, managing firewalls, routing, application integration, security, PowerShell, monitoring. So there's a whole new world of skills to learn. And as DBAs, I don't feel that we typically spend most of our time patching and backing up databases. In fact, that's something that's done fairly infrequently, and our job is much more around managing the data, security, performance tuning, optimization, and all of those things are still relevant and needed, even more so in a cloud world. The next point is around cost, and I think that this comes down to roles and responsibilities as well, but whose job is it to right-size the service tier? And that's relevant whether we're running in virtual machines or running in PaaS services. And I really think here that back to that example with a virtual machine running on premise with 32 or 64 cores that's running at 50% or 70% busy, what's the organization's attitude towards cost and risk, and how ready are we to accept running hot in Azure, so saving money but running virtual machines at 80 or 90% or more CPU utilization and memory utilization, and really thinking about who is worrying about this on a day-to-day basis, and who's taking responsibility for achieving that right balance of cost and performance. Third point is around testing. So how do we invoke a DR test? So many organizations have regulatory requirements to invoke a disaster recovery test once a year. How do we manage non-production environments, and what's the roles there? And then the final point, again, going back to expectations, PaaS means no maintenance. So, is that really true? Does Azure SQL Database mean absolutely no maintenance? We know it means no patching. We know it means no backup. We know that there are options to turn on high availability and disaster recovery solutions, but is there really no maintenance? And that's not true. So we're still required to perform index maintenance and stats maintenance. And I really think that performance tuning and optimization is part of looking at expensive queries, reviewing the indexing strategy, making sure that we're keeping up with application changes and the database schema as data volumes grow. The indexing and stats strategy matches. So this is closely intertwined with cost and performance as well. Hopefully that's been useful. I've talked through the kind of 5 key mistakes and some examples of each of those. What I wanted to move on to now was really thinking about the experience and how we can mitigate the experience. So I'm going to provide some recommendations that are my experience, so experience-based. I've got a collection of resources, and I also want to recommend the Microsoft Cloud Adoption Framework, CAF. So I'll talk through that in a bit more detail. Essentially, CAF includes 4 primary phases: plan, ready, adopt, and govern. And there's a lot that we can take from the CAF framework, which means that we can leverage the experience that Microsoft have got across thousands of customers. We don't need to go through that learning curve or journey ourselves. So there's a real big opportunity here to improve that. My next kind of comment was experience counts. So getting the right experience and having the right experience is really important. If you don't have the right experience, then attend training, engage a partner, get some technical design assurance on your project, and really make sure that you've got the right skills and you're comfortable and confident when you're going into this type of project. And then iterate and expand. So I said this earlier, but I really think that it's important to start small and build your knowledge, build your skills and experience, and then move forwards with things. So don't try and do a big bang approach of a whole data center migration if it's the first workload that you're moving to Azure. Start with a single application, start with dev test, provide your DR, and build it out from there. So mitigation 1, how do we approach cost optimization? And there's a number of areas here where we can really focus on it. So thinking about cost, the first recommendation that I've got here is around the Microsoft Assessment and Planning Toolkit, MAPS. And MAPS allows you to install an agent and run a data collection for an on-premise data center. And this will provide a recommendation around what that resource workload will cost in order to run in Azure. And when you're running that performance collection, it will base those recommendations on two options. The first is a performance data collection, which will recommend the VM size, and it will recommend the most appropriate disks, whether you require standard or premium based on the IOPS. And the second option is as-is collection. So it will provide like for like compared with your on-prem environment. And to take an example here, if we have an on-prem server with 24 cores with 20% CPU utilization and 16 gig of memory, which 40% is used, the maps tool allows us to add a comfort factor, so we can add, say, 30% overhead on. And the recommendation, if we use the performance data collection in that example, would be about 6.5 cores of CPU and just over 8 gig of memory. So that will right-size the workload or right-size the VM based on that performance characteristics and requirements, whereas the as-is recommendation would match the VPUs, the CPU cores, and the memory with the on-prem server. So really think about what's the most appropriate way and whether the method and whether this is an opportunity to right-size or to optimize the VM specification. The great news with Azure is that you can start small and upsize, or you can start big, as in like for like, and then you can downsize over time. But that's a really good tool to kind of give you some insight into what the cost might be. Relatively low effort to download and install it and run a data collection. Of course, it's important that the data collection period is representative of your typical workload, because if you run it during a period of low activity, then expect the recommendations to be lean, and we might be disappointed there with undersizing those virtual machines. Second point is an Azure TCO calculator. So this will look at and provide you with some guidance around total cost of ownership from Azure. So that's a good indicator also. Again, low effort to kind of get an answer out of that, but you plug in the VMs and the storage sizes, and that will give you the expected costs. And then the final point is around using Power BI to manage costs when you're running in Azure. And there's a really good guide. If you're buying Azure through an enterprise agreement, then there's a guide to connect Power BI to your Azure enterprise agreement bill, which will allow you to visualize the bill and understand which resources and which areas of the subscription are most costly. I've included a small screenshot there, and Coeo is a cloud solution provider, CSP, and we've built a number of aspects of billing, reporting, and mechanisms on top of the solution to enable us to help customers spot these trends and patterns early and really make sure that they're keen and on top of billing wherever possible. Second point around mitigation is readiness. And first bit I'll touch on there is landing zone deployments and using blueprints. So Microsoft have published a number of blueprints which include identity, network and connectivity, business continuity and DR, and deployment mechanisms. So you don't need to start with a vanilla an empty Azure subscription. You should use one of these blueprints. And there are blueprints for migration landing zones, Azure Foundation, enterprise scale. So there's a number of varieties of those, and I'll talk about those in a little more detail on the next slide. But you really shouldn't be thinking about starting with a blank piece of paper here. You can leverage one of those existing blueprints already. Second point is around skills and training, and Microsoft Learn has a great resource. You're already at SQL Bits, so you're doing the right things to learn more, but there's always more to learn here. And then I wanted to talk briefly about the certification path. So Microsoft have redesigned certification to be role-based, and this is focused in Azure Data and AI. And there are essentially three pathways there. There's the Azure Data Science Associate, which covers machine learning models and algorithms. There's the Azure AI Engineer Associate, which covers cognitive services, machine learning, and knowledge mining. And then the Azure Data Engineer Associate, which includes building a solution using structured and non-structured data and streaming data sets. So all of those pathways are really good and are a great starting point to build your first data analytics solution in Azure. There's also tons of hands-on experience opportunities. and Microsoft host immersion events, including at the Reactor in London, but more frequently using Teams and online. There's good events pages at Microsoft.com, so check out those immersion events. So they're one-day events to build analytics in a day, AI in a day, dashboard in a day. So Coeo run a number of these, and many partners do too. So get yourself signed up to one of those events and try and get hands-on and get learning. And then the final point there is around automation and PowerShell. So really invest in PowerShell skills and automation. So think about startup and shutdown of virtual machines, provisioning resource groups, and using ARM templates, Azure Resource Manager templates, in order to automate many of those steps. So don't do anything by hand, basically. Same as a normal DBA method of working. So really just apply everything that you know from your SQL Server world to Azure. Third area is around design and some ideas about how we can mitigate that. I mentioned these frameworks and blueprints. Got some more links here. So under the Cloud Adoption Framework, Microsoft have created an AI landing zone, and you can download that. That's a set of PowerShell scripts which enable you to deploy that blueprint. So really, really good starting point if you're in that world and that use case scenario matches. The second is a reference architecture around advanced analytics architecture. And again, there's some solution blueprints and platforms that you can take advantage of. And the third point is Microsoft have launched a series called Well Architected. And under this, they've provided an automated enterprise BI solution using Azure Synapse Analytics and Data Factory. Again, no need to start from foundation. There's three really, really good frameworks there which you can take advantage of, and many partners have developed their own frameworks, and Coeo by no means unique, but we've got our own portfolio of frameworks which suit the common patterns and deployment solutions that we see for customers. So I'd be happy to have a conversation if that's interesting. Under papers, there's some really good guidance under Azure security best practices and patterns. So really make sure that you leverage and can learn from those as much as possible. And thinking about blogs, so one of my colleagues, Roberto, wrote a blog on making the most out of your Azure disks and storage pools. And this is a really good way to make sure that you can achieve the right network bandwidth and throughput, because virtual machines are limited in their bandwidth backends to storage. So there are some good tips and techniques there to take advantage of. Mitigation 4 is around performance, so really thinking about how you can create a benchmark, deploy monitoring tools, engage the business users in testing, I think here, prior to migration, you should have undertaken a thorough benchmark, know what your cache ratios are, identify key store procedures for critical workloads, capture the execution plan, really make sure that you know what good looks like prior to undertaking the migration. And that will really make sure that you're set up for success. And the final point is around knowing resource limits. So there are limits around subscriptions and resource groups on CPU cores and on storage accounts also. So there's good documentation around those limits. So take a look at those and make sure that you're familiar with them. The final point around mitigation 5 for maintenance is really to define your operating model. There's a lot of good content in the CAF framework around governance, which will help here. Understand and make a decision around the balance of in-source versus partner resources. So what elements from an operational point of view are you going to undertake and own internally versus engage an external supplier to take responsibility for? Define those scope and responsibilities, undertake that testing, and build the governance framework. So understand who's going to be responsible for cost management and service tier optimization. And then the final point here is database maintenance is still needed even in a PaaS world. So configure your favorite database maintenance solution. I've included the link to Ola Hallegrand's solution. It's globally one of the most popular maintenance solutions. We make extensive use of it at Coeo. So really think about how you can take advantage of that and extend that into Azure as well. The final summary. So I tried to kind of produce a quick summary here. So mistake number one is cost. Think about the cloud adoption framework, planning, controls, and reporting. Mistake number two is around readiness. Don't underestimate skills, training, certification, and the value of hands-on experience. Mistake number three is around design. Utilize the frameworks, blueprints, and well architected. Mistake number four is around performance. Capture a benchmark before you move to Azure. Decide your performance goals and objectives and engage the business early. Mistake number five is around maintenance and define the scope and responsibilities and testing, and make sure that you're really clear on what those pathways are. And I've just included as a recap there the cloud adoption framework stages: plan, ready, adopt, and govern. And I think that customers that we've seen who take advantage of CAF framework, and when we've collaborated on these types of projects, they've benefited enormously from those solutions. So really don't hesitate to take as much as you can from those predefined frameworks and solutions. Thanks very much for listening. I'm aware that this is a virtual session, so your opportunity to ask questions is pretty limited. I've included my Twitter handle and my email account. If there's anything there which you found useful or you'd like to discuss further, I'd totally be happy to have a conversation in whatever medium you feel best. It just leaves me to say thanks very much for listening. I hope you have a great SQL Bits, and good luck for your Azure data migration projects.